Hi everyone. Today we're going to study Newton's law of cooling. According to Newton's empirical law of cooling, the rate at which the temperature of a body changes is proportional to the difference between the temperature of the body and the temperature of the surrounding medium, the so-called ambient temperature. In symbol, we say that d of capital T over dt is proportional to capital T minus capital T sub m. In equation, we write like this. D capital T over dt is equal to K times the quantity capital T minus capital T sub m, where capital T is the temperature of a body at time small t. The T sub m is equal to the temperature of the surrounding medium. The d capital T over dt is equal to the rate at which the temperature of the body changes. And the K is the constant of proportionality. If capital T sub m is a constant, it stands to reason that K is less than 0, meaning K is negative. Now let us solve this equation using separation of variables. The equation now becomes like this. D capital T all over capital T minus capital T sub m is equal to K dt. Then we will take the integral of both sides. The integral of the left side is ln of the quantity capital T minus capital T sub m equals the right side is kt plus the natural log of the constant. In this case, this natural log of the constant we will transpose to the left side. And then we will apply the law of logarithm. The left side now becomes ln of the quantity T minus T sub m all over capital C equals kt. And from here, we're going to show this equation in terms of exponential. It means the left side becomes capital T minus capital T sub m all over C equals the right side becomes exponential of the product kt. Let us cross multiply the C to the right side. So we have this capital T minus capital T sub m is equal to the constant C times E raised to the product kt. Let us isolate this capital T, meaning this negative T sub m we will transpose to the right. And we have now this equation capital T equals capital T sub m plus C times E raised to the product kt. This is now the formula for the Newton's law of cooling. Example 1. If in air at 25 degrees Celsius, an object will cool from 100 degrees Celsius to 75 degrees Celsius in 1 minute. Find its temperature at the end of 3 minutes. Also, find the time if the temperature is 45 degrees Celsius. Our formula for the Newton's law of cooling is here. In our problem, one given here is that T sub m equals 25. That is this 25 degrees Celsius. Let us substitute this value in our formula for the Newton's law. So it becomes like this, and we consider this to be equation 1. If we analyze our problem, there is a given that says when T equals 0, capital T equals 100 degrees Celsius. So we write here 100. Also, when T equals 1, the capital T is 75 degrees Celsius. So we write here 75. We have two problems here. Let's begin with the first problem. Find its temperature at the end of 3 minutes. In other words, let us find capital T when small t equals 3. We have here step 1. Let us solve for C in our equation 1. What we're going to do is to substitute t equals 0 and capital T equals 100 in equation 1. So it becomes like this. Then let us simplify. This k times 0 will be 0, and this is the exponent for the e. Therefore, e raised to 0 is simply 1. It means to say, this equation now becomes like this. If we transpose this 25 to the left side, so it becomes subtrahend to 100, so the value of c is 75. Next step is to substitute the value of this c in equation 1. So equation 1 becomes this new equation. We regard this now as equation number 2. Step 2, let us solve for e raised to k. We are going to substitute t equals 1 and capital T equals 75 in this equation number 2. So it becomes like this. 75 equals 25 plus 75 times e raised to k times 1. The number 25 here, we will transpose to the left side. It becomes negative. So we have 75 minus 25 equals 75 times e raised to k. We simplify the difference on the left side. We have 50. We divide this equation by 75. So we have now e raised to k equals 50 over 75. We can simplify the fraction into 2 over 3. Let us now substitute this value for e raised to k, which is 2 over 3 in equation 2. This is now our equation 2, and it becomes like this. T equals 25 plus 75 times the quantity 2 over 3, that is raised to the variable t. This is now our equation 3. Step 3, let us now substitute t equals 3 in equation 3. So, it becomes like this. We can use our calculator to simplify this, and we will get the value of capital T. And the value is 47.22. Remember that this T is a temperature, so we write our unit in degree Celsius. This is our answer in problem letter A. Now, the next question here is, find the time if the temperature is 45 degrees Celsius. Or we say that, find small t if capital T equals 45 degrees Celsius. We're going to substitute capital T equals 45 degrees Celsius in equation 3. Then we will solve for small t. Equation 3 becomes like this, and we will simplify. This number 25 we will transpose to the left side. It becomes the subtrahend for 45. And then the 45 minus 25 becomes 20. Then we divide this equation by 75. So on the left side we have 20 over 75 equals the fraction 2 over 3 that is raised to t. Let us simplify the left side into 4 over 15. Take note of this equation. It is in exponential form that we can write as logarithmic form, which means that t is equal to the log of the quantity 4 over 15 to the base 2 over 3. Using our rule for the logarithm, we can express this expression into t equals log of 4 over 15 divided by log of 2 over 3. We simply use our calculator to find the value for the t, and this is equal to 3.2599. Small t is about time. It means the unit of measurement here is minutes. This is now the answer for problem B. Example 2. A thermometer is taken from a room where the temperature is 20 degrees Celsius to the outdoors where the temperature is 5 degrees Celsius. After 1 minute, the thermometer reads 12 degrees Celsius. What will the reading on the thermometer be after 1 more minute? When will the thermometer read 6 degrees Celsius? Our Newton's law of cooling formula is here. Based on our problem, the T sub m is equal to 5 degrees Celsius, as we see in here. So let us substitute this value to our formula. So the formula becomes T is equal to 5 plus C times e raised to kt. This is our equation 1. Based on the problem here, we can collect some of the given. One is, when small t equals 0, capital T is equal to 20 degrees Celsius. Also, when t equals 1, the capital T is equal to 12 degrees Celsius. Now, the problem letter A. What will the reading on the thermometer be after 1 more minute? We can rewrite the problem as find capital T after 1 more minute. It means the T is equal to 2. So for step 1, let us solve for C. Let us substitute T equals 0 and capital T equals 20 in equation 1. So it becomes like this. Let us simplify further. So we have this 20 minus 5 is equal to C. And the difference here is the value of C, which is 15. Now let us substitute the value of C in equation 1. Equation now becomes like this. Capital T equals 5 plus 15 times e raised to kt. We will regard this as equation 2. Step 2 now is to solve for e raised to k. We will substitute t equals 1 and capital T equals 12 in equation 2. Equation 2 now becomes like this. 12 equals 5 plus 15 times e raised to k times 1. K times 1 is simply k. Then let us solve for the e raised to k. This constant 5 we will transpose to the left side, and the difference 12 minus 5 will be 7. We divide the equation by 15 to isolate this e raised to k. So the value of e raised to k equals 7 over 15. Next, let us substitute the value of e raised to k in equation 2. So we have t is equal to 5 plus 15 times the fraction 7 over 15 raised to the variable t. This is now our equation number 3. Then we go to step 3. Let us substitute t equals 2 in equation 3, and we can solve for the big T. So it becomes like this. Using our calculator, we can simply get the value of this capital T. So the T is equal to 8.27. Remember that the capital T is about temperature, so we write the unit of measurement as degrees Celsius. This is the answer for the problem A in this example. For the problem B, it says, when will the thermometer read 6 degrees Celsius? In other words, this is problem B that says, find small t if capital T equals 6 degrees Celsius. So let us substitute the capital T equals 6 in equation number 3 and solve for t. So it becomes like this. 6 equals 5 plus 15 times 7 over 15 that is raised to t. Let us transpose the number 5 to the left side, so we have the 6 minus 5. The difference will be 1, then let us divide the equation by 15. It becomes like this. We see here that it is now in exponential form. We can convert this into logarithmic form and it becomes like this. T equals the log of 1 over 15 to the base 7 over 15. Using the law of logarithm, we can express t as log of 1 over 15 divided by the log of 7 over 15. Using calculator, we can simply get the value of small t, and that is 3.55. The small t is about time, so the unit of measurement is minutes. This is now the answer for the problem B. I hope you learned something from this video. See you again next time.